Now the process is still going to be the same, but we're going to have the one major difference is going to be at the very beginning. So our step 1 is in behavior, right? In behavior. All right. So since we know that the lead coefficient is greater than 0, and the degree of our function is 3, which is odd, we know that our end behavior looks something like this. It's going to go down as x approaches negative infinity, and it's going to go up as x approaches positive infinity. All right, step 2. Our possible rational roots, that p over q stuff. So first thing we need to know, the constant is 24, right? So what are the possible factors of 24? Well, we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Come on, 6. Now, Q is really nice, right? Because our lead coefficient is just 1, so the possible factors of 1 are, well, 1. Since P over Q, since our Q is 1, our possible rational roots end up being plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Now, next step, right? Step 3, put it here, is Descartes' rule of signs. So Descartes' rule of signs says we want to check the amount of times that we switch signs. So if we go x cubed plus 3x squared, no sign change. Minus 10x. So there's a sign change between the positive and a negative. Minus 24, no sign change between negative 10 and negative 24. So we have one positive real root. This means we either have, the other ones must be. If something's not positive, it's negative, right? But remember, this is 2 or 0, because we have to take into account we need to subtract by multiples of 2. So we have 2 or 0 negative real roots. Now, step 4 is our favorite step. Everybody loves synthetic division, right? Synthetic division. So I'm going to start this on another page, right? So let's do a new page here. And let's look at our synthetic division. Our synthetic division says, remember, our function was f of x is x cubed plus 3x squared minus 10x minus 24. So when we look at this, we're going to put our box here, and we're going to bring down our coefficients. 1, 3, negative 10, and negative 24. Draw our line. First thing we want to check, I always start with 1. Bring the 1 down. 1 times 3 is, 1 times 1 is 1. There we go. Whoops, go away, little thing. 3 plus 1 is 4. 1 times 4 is 4. Negative 10 plus 4 is negative 6. 1 times 6 is negative 6. This is negative 30. Now, this is not the 0 that we're looking for, but we do know, remember, that f evaluated at 1 is negative 30. It's a piece of information. I'm going to try negative 1. 1, 3, negative 10, negative 24. Draw our line. Bring the 1 down. 1 times negative 1 is negative 1. 3 minus 1 is 2. Negative 1 times 2 is negative 2. Negative 10 plus negative 2 is negative 12. Negative 1 times negative 12 is 12. Negative 12. Okay, well, we know that when x is negative 1, our function is negative 12. Still not exactly what we're looking for. Let's try 2. 1, 3, negative 10, 24. Draw our line. 1. 1 times 2 is 2. 2 plus 3 is 5. 2 times 5 is 10. 10 minus 10 is 0. 2 times 0 is 0. 24 plus 0 is 24. Well, that didn't help us. But we do still know that f evaluated at 2 is 24. Alright, let's try negative 2. 1, 3, negative 10, negative 24. Bring our line down. 1. Negative 2 times 1 is negative 2. 3 minus 2 is 1. Negative 2 times 1, negative 2. Oh, this is looking good. Negative 10 plus negative 2 is negative 12. Negative 12 times negative 2 is 24. And there's our happy face. We know that when x is negative 2, our function is 0. So this is one of our first factors. So now we can write f of x equals x minus negative 2. Remember, because you always have to subtract whatever's in this box, times x squared plus x minus 12. Now, we can, of course, we can rewrite this as x plus 2 because that's prettier. And we can factor x squared plus x minus 12. What multiplies to get 12 and adds, subtracts, I guess I should say, to get 1. Well, our answers are 4 and 3, right? Now, this needs to be positive, so the 4 needs to be positive 3. So now, we have factored our polynomial. Now we can go back to the previous page and we can graph it. So our function is x plus 2 times x. What was it? Hold on. X plus 2 times x plus 4 times x minus 3. So our x-intercepts are going to be at negative 2, excuse me, negative 4, and positive 1, 2, 3, right? Because when we look at x-intercepts, we're setting x plus 2 equal to 0, x plus 4 equal to 0, and x minus 3 equal to 0. Now we know from our end behavior here, we're going to go down at the end, at one end, and up at the other end. We also know that we're going to go through. Now where we cross here is always good to know. It's always going to be at your constant. So when x equals 0, what we have left, if you cover up, if I cover all of these up, what's left when x equals 0 is negative 24. So this is the point where it crosses y-axis. And there is your beautiful odd polynomial. I hope this helps and makes things make a little more sense.